Welcome to solving linear trig equations. So we're going to work through some examples and identify any key steps involved in solving a trig equation. So our first example is to solve for 2 tan x plus 5 equals 7, and it's on the interval 0 to 2 pi. First step is to isolate for tan x. Subtract 5 from both sides, and then divide both sides by 2. So we want to solve for where tan x is equal to 1. So this is an equivalent equation to the one given above. We're going to solve this without a calculator. So we need to solve first for our related acute angle. And the related acute angle can be determined by finding the tan inverse of 1. So using our special triangles, we know that if we have an opposite side of 1 and an adjacent side of 1, our angle will be pi over 4. Next, we need to determine which quadrants we are dealing with, and since tan is positive, we need to work in quadrants 1 and 3. So make sure to include a picture of your rotation angles. Since we know the related acute angle is pi over 4, let's include that in our diagram. And now we can solve for our x values. So we see that x1 is going to be pi over 4, and our second solution will be pi plus pi over 4. Finding a common denominator, you can show that the second solution is 5 pi over 4. So therefore, the solutions are x equals pi over 4 and 5 pi over 4. So you see we have two solutions, and if we go back up to our diagram, here is where the line y equals 7 intersects the graph 2 tan x plus 5 within the interval 0 to 2 pi. In our next example, the only difference is that we have a larger interval to deal with. We're going from negative 2 pi to positive 2 pi. So first of all is to isolate for sine theta. Next, simplify each side of the equation. And finally, divide both sides by 12. Same as before, let's find our related acute angle. So related acute angle is the sine inverse of positive 1/2. Always use the positive ratio. Let's draw our special triangle. Sine is opposite over hypotenuse. So we have 1 over 2. Which tells us that we are looking for the angle pi over 6. And there's the rest of that special triangle. Again, determine our quadrants. Since sine is negative, we're looking at quadrants 3 and 4. Remembering that our related acute angle is pi over 6, let's include that in our diagram. Now we can determine theta 1 and theta 2. So theta 1, if we find a common denominator and simplify, we end up with 7 pi over 6. And theta 2 will end up with 11 pi over 6. Recall that our interval goes from negative 2 pi to 2 pi. If we go back to our diagram, we have found the following two solutions. There's theta 1, 7 pi over 6. And here's theta 2, 11 pi over 6. We still need to determine these two theta values here. To determine our remaining two values, all we need to do is go back our period. So go back negative 2 pi. And same thing for the other point. I go back the period. So go back negative 2 pi to find the 2 points that are going in the opposite direction. And we can see that from our diagram as well. In our diagram here, we're looking for this point here, theta 3, and we're looking for this point here, theta 4. We can figure them out with the diagram, or we can use the fact that they're 2 pi radians in the opposite direction. So theta 3, we can take 7 pi over 6, and we can minus 2 pi, And if we find a common denominator, that's going to be 7 pi over 6 minus 12 pi over 6. So that gives me negative 5 pi over 6. So that's theta 3. And theta 4, again, is 11 pi over 6 minus 2 pi. We go back a full cycle. And that's going to be 11 pi over 6 minus 12 pi over 6, which is negative pi over 6, which again we could have just determined by looking at our diagram. So you see for this example, we have 4 solutions. So theta can equal negative 5 pi over 6, negative pi over 6, 7 pi over 6, and 11 pi over 6. And again, that is because our interval goes from negative 2 pi to positive 2 pi. And our last example. This time, we're looking for where 2 cosecant x equals negative 5. We haven't seen the graph of cosecant, but it's the blue graph shown here. And we want to find out where it intersects the line y equals negative 5. And we see there's going to be 4 solutions. And that is because we're going from 0 to 4 pi. From 0 to 2 pi, we would have stopped right here and only had the first 2 solutions. But we're now going to 4 pi, which gives us 4 solutions. So let's look at how we solve this trig equation. First off, I would divide both sides by 2 so we can isolate for cosecant x. And we get that cosecant x is equal to negative 5 over 2. Recall that cosecant is equivalent to 1 over sine of x. Since sine of x is in the denominator, I would flip both sides of the equation. So we get that sine x is equal to negative 2 over 5. This ratio is not one of our ratios from our special triangles. So we're going to have to use our calculators to determine the related acute angle. So our related acute angle for this example is equal to the sine inverse of 2/5. And we also know that sine is negative in quadrants 3 and 4. So next step, of course, is to draw our 2 rotation angles, our first 2. Our related acute angle is right here, our RAA. So our first x value then, x1, is equal to pi plus sine inverse of 2/5. And our second angle is going to be 2 pi minus the sine inverse of 2/5. Remember, we're going to 4 pi this time. So what we need to do now is to find the next 2 angles, which will be, if we go back to our diagram, this will be 2 pi units over, the repeating pattern for our graph, and again, 2 pi units over. So all we need to do is add our period to each of our solutions. So x3 will be equal to pi plus the sine inverse of 2/5. But then we're going to add 2 pi. So if we like, this is 3 pi plus the sine inverse of 2/5. And then x4 is equal to 2 pi minus the sine inverse of 2/5 plus, again, 2 pi. So this gives us 4 pi minus the sine inverse of 2 over 5. And then the rest is just calculator work. So if you take out your calculator, you'll get the following x values. x1 is going to be 3.55 radians. x2 will be 5.87 radians. x3 will be 9.83. And x4 will be 12.15 radians. Again, you can keep on adding 2 pi to find more answers, but we already know that we're going from 0 to 4 pi, and 4 pi is approximately equal to 12.57. So you can see our last answer is just below our interval max. So this is where we should stop. So here's a summary of how to solve a linear trigonometric equation. First of all is to isolate for your equation, and once you've done that, use a special triangle or calculator to determine your related acute angle. Use the sign of that equivalent equation to determine which quadrants the angles are in. Sketch your two primary angles, and then determine all your possible solutions in a given domain. Follow those steps and you should be able to determine all the solutions for the equation. And here are the questions that you should try. Good luck.